Alright, so let's go back here. So what we're going to take a look at is something called the turning effect, right? So the turning effect is what we call the moment. Right? So watch this here. I'll try to only with the writing going. Alright. So let's take a look at what is the moment, right? Let's ignore the handwriting for now, right? Right, I'll give it a note just now. It's called a turning effect. So how do we find the moment, right? To find the moment, what we do is we take the force that's being applied. We take the force that's being applied and we multiply it by the perpendicular distance. I'll give you a note something just now, right? Perpendicular distance from the pivot. So here's what that means. It means that if we were to take this force and multiply it by the distance from the middle here, which we call the pivot, right? If we were to multiply the force here by the pivot, the distance on the pivot, we will get a moment, right? So that simply means that the further away we go, the bigger the moment. Are you okay with that? So the further away you go from the center is the bigger the moment. So let me clear all of that. Right? So for example, if I were to put it further away, the further away I go, the bigger is the moment, right? If I go more to the end, the moment is much larger. So that's the reason why your door puts the handle way down to the end. Because your movement is largest. Think about it. Here's the pivot, right? So the further away you go, the bigger is the moment. That's okay? If you put the door handle in the middle, you'll have to apply a greater force to open and close. All right? So if you look here now, if I place the object here, how does that turn? Clockwise or anti-clockwise? How does the plank turn? Right. So some forces could create a clockwise moment, or some could create a anti-clockwise moment. Okay? So we have two types of moments. Right, Sasha? We have clockwise moments and anti-clockwise moments. Suppose I wanted now, here what I want to do, right? I want to leave this 5 kilogram mass right in. And I want to bring a next one on the opposite side. But I want to get back the plank balance. How do I do that? Put them at the, yeah? Right, so put them at the same distance away. That's okay? What do they have in common? Same distance from the pivot, same weight, but looking for the word that we learned today. They have the same moment. Right? How do you find moment again? Moment is the force by the distance from the pivot. That's okay? So these two objects have the same moment. If I were to move it further away, what to do?
Move on to the.
Move this one further away. All right? But here's what I'm going to do now. I am going to use the instead of the fire extinguisher, I want to balance this by using the trash can. Where do I put the trash can?
Close up.
Right? I want you to tell me exactly where to put the trash can.
Second point.
Second point? You sure? Are you agree?
Yes.
No? Third one? Think about it. Think about it. I want you all to get it right.
Second. No. It's 5 and that's 10. Right. So we have to half of the distance from the other side.
Right? That's all, yeah. Go on. Forward. Put it on the one. Put it on the fourth. Second. Right, so let me see. So we have 1 stroke, 2 stroke, 3 or 4. Where do I put it? 1, 2, 3 or 4? 4.
So which one is two? Because I'm thinking I'd be second one from the pivot.
You are starting from the pivot. All the counting happening from the pivot. So here's 1.
Oh yeah, two.
2. Put it in 2. Right. Who's in 1? Who's in 2? Show my hands. Alright, most people saying 2. Let's see what happened then. Check and see if it lights up.
Yes.
Did it light up? Yep. Balance. Everybody okay with that? So what do those two have in common? The red fire extinguisher and dustbin. They both have same moment, right? If you work out the moment of the trash can and the moment of the fire extinguisher, the same. Everybody okay with that? So what you just learned, there is something called the principle of the moments. Principle of moments. That's all.
That's it. I'm so good. My stomach is getting
That's not. Right, yeah. Sorry. Where's the accent? The mass of the extinguisher is 5 and the trash can is 10. That's okay? Right, so I'm gonna make it slightly harder now. I am going to put 2 fire extinguishers on one side. And I want you to give me a little eye there. Where do I put the trash can, right? Hold on, eh? No, you gotta watch where I'm putting it, right?
No, put it on the end. Oh, okay.
That's not. What's that? Right, yeah, go ahead. Where do you think the trash can has to go?
I think
So count the lines coming up online, you can message as well. On stroke 1, 2, 3, or 4. Right? This is 1, this is 2, 3, 4. What y'all think? 3, 4. Are you in different things? Then what do you think? Adrian, what do you think? Where do I put the dustbin? Where does the garbage bin go? 4, 3, 2, or 1? 3, okay. Who said 1? Who said 2? Who said 3? 4? 4? Let me try 4. Let's try 4. Too heavy. Right? Too heavy. Let's try 2. Too light. Let's try 3. Right? 3. So what you're observing there again is the principle of moments. The moments to the left equal to the moment to the right. What do you call the moment to the left again? Clockwise or anti-clockwise?
Anti-clockwise.
And on the right is?
Clockwise.
So the law that we learned here is that the sum of the clockwise moments equal to the sum of the anti-clockwise. I want to show you via calculation. Let's pretend each of these lines is 1, right? So let's see. 5 I'm using these numbers for now. Ignore the forces, right? So 5 by 4, that's how much? 20. Here's 4, right? And here's 2. 5 by 2 is what? 10. 20 plus 10 is 30. Let's check out the right side now. Here's 10. And it's on the third mark. 10 by 3 is 30. So both of them are equal. Right? So that means that the anti-clockwise moments is equal to the clockwise moment. Is that okay with that? So the law that we're learning there is called the principle of moments. All right? Online, are you okay with that? Emily, are you okay with that? Amara? Yeah, 5 by 2 is 10 and 4. But I'll use actual values just now, right? I shouldn't be using 5 and 10, I should be using 50, but I didn't want to bring that in as yet. Right, let's clear up this. That's not. Right.
Wait a second.
Right, sorry. Right, so we just trying a few more, but you don't catch the principle of it. Make sure the moments on the left equal to the moments on the right. And what would happen if we place it in the middle? Anything will happen? No, nice. So there's a little game here that you could play. Let me try level. I feel like the smart. You can try level 4.
Yeah.
No. Let me try level 3. Right. Yeah, we'll remove the pillar, but where should Francesca, that boy or girl?
Boy.
Boy, where should Francis go?
On this one.
What you all think?
This.
1, 2, 3, or 4? Everybody agree on 1? Are you saying no? Nice. We got 1 right. Online, you all can message to our online. What is the mass? Oh, nice. I like this one. Here's what it's doing now. we have to place 15 at certain points, right, to help us figure out what the mass is, right? So which one heavier, the rock or the bricks?
No, but it's still. You didn't check. Okay.
So what to do, move it, right?
Yeah.
Yeah. I just gotta move it a little bit. Let's see what happened there.
Yeah.
So what's the mass? Since they equal,
Sorry.
what do you all think? It level now. So what do you all think the mass is? This one is 15 and it's at stroke 2. This one is something at stroke 1. So what to put?
Oh yeah, it's 15.
Let's see, I hear in 30 and I hear in 10. What do you all think? Would it be more than 15 or less than 15? More than, right? So where to go?
CSEC.
Well, let's show it. Otherwise, let's start over if we lose her.
Yes.
Well, let's show. Nice, well done. Right, because the mass should be double, right? What will happen next? Would it fall over, or will it stay level, or will it go to the right? Think about it there. Now, one is 40 and one is 20. Pay attention to where 20 is at 20 in the middle here. What do you think? Which one? Would it fall clockwise, anti-clockwise, or stay right there? I hear everything. I hear clockwise, I hear anti-clockwise. I hear anti-clockwise. Anti-clockwise. In the back. What do you think? Anti-clockwise? Yeah? Alright, let's see. So this is 20. So I use averaging, right? This is 20. How far is it away? 1, 2, no, 3.5. So multiply 20 by 3.5. So that'll be 60 and so that's 70.
Yeah.
Right. Oh Lord, if I write that. Here's what? 40 by 1, 2. So this is 40 by 2, which is 80. So therefore the 80 bigger than the. So we could probably choose. We could choose anti-clockwise. Nice. Last one I think. How much is that? 3. No, too long. Oh, we're gonna finish it. We'll finish it out?
Yeah.
Nah.
Oh.
But let's mark it. We're gonna think, nah. 45 going already. Oh, we'll keep it. Oh, you come back after if you good. I'll leave it right there. All right, nice. Head up movements. Head up movements. Who didn't get onto the physics elements as yet?
None.
Oh, what do you mean, Alma?
Nothing. Oh,
Maybe
Oh, they didn't get
that's
it.
the elements.
that's the we stand on to go. No waste. All right, that's how. I'll give you a question. I'll then come to your question, right?
We have tests and I kind of want to go through indices.
Hmm?
We have tests and I kind of want to go through indices. Yeah, I get two. City foods, no, yeah, city foods.
All right, ready? So we're gonna take a look at something called moments. As I told you all, right? Moments measures, right? It measures the turning effect of a force. All right. So if I give you a force being applied here, right? And the distance from the pivot is D. right? This dot here is your pivot, right? We call that your pivot. You do online already? And last week?
All material.
And the same in the back still. Or it could come higher up. Moment of a force, right? How do we find the moment of a force? The moment of a force is the force multiplied by this distance here. We call that distance the perpendicular distance from the pivot. Anybody could tell me what the SI unit will be? Right? Forces in newtons and distances in meters. Newton meter. All right. So just make a little note of these things. And then I have a small example here. I have 5 forces. I want you to tell me which of these forces are clockwise and which are clockwise. Think about it. Write it down first. Right. So I want you to draw this and tell me which is which is clockwise, which is anti-clockwise, which is what. Right? So you can figure out all 5. Be careful with 3, 4, and 5, right? Ready? Almost? I'll give you a little bit of doing that. Okay. Wait, okay. Good. Kind of high. Yeah, but- Okay.
Right. Right.
Nothing.
Right, sorry. Nice, let's go. So F1, what y'all think? Clockwise or anti-clockwise? Anti-clockwise, nice. F1 is anti-clockwise. What about F2? Right, here's how you can check, right? Here's how you can check. What I like to do is try something like this. Take your 2 fingers, one of your fingers on the force, one of them on pivot, right? And then the one on the force, allow that finger to move in the direction of the force and see how it will turn. One on the pivot, one on the force going down. So F1 is anti-clockwise. F2 now, one on the pivot, one on the force, it will turn clockwise. Everybody clear with that? Right? What about F3? F3 is what? F3 pivot turning anti-clockwise. F4, Lucas. Right? Pivot force clockwise. Let's pick somebody online now. Let's pick somebody online. Looking like
Mr. Paul.
who? You go reply earlier. Who's this silly?
See.
Tyra. Tyra, what do you think F5 is? Kyra? Kyra, you there? Kyra's thing, or Chidan thing clockwise. Let's pick somebody here. Sasha. What do you think? Clockwise, anti-clockwise? You're not sure? You're not sure? Crystal. What do you think? What do you all think? Nothing. Right? No, so you can see probably that column. They want to say that. But basically the question I ask is if it's clockwise or anti-clockwise, and it's not. And the reason for that is that the force is at the pivot. So if the force is at the pivot, this value becomes 0. And 0 by anything else. So a force like this has no turning effect. Right? So it has just put 0. Right? No turning effect. So put F5 has no turning effect. F5 has no turning effect. F5 has no turning effect. Everybody okay with that? Next subheaded, equilibrium. Right, how many people here not in the WhatsApp groups? WhatsApp group. You get much man say you wasn't in something? Sorry. Get much man tell me you wasn't in something?
Yeah, but.
Now in the WhatsApp group? Lucas? Right, you are in city. If you any WhatsApp group, you'll tell that, right? How many not on the elements? That is both.
What I love, yeah, when I just think that whenever you look out to it.
Right. You'll come next now, right? You'll come next now and everybody. Right. So I want you to head up equilibrium. So smaller note, for a system to be in equilibrium, for a system to be in equilibrium, for a system to be in equilibrium, the following two rules must hold. The following two rules must hold. Number one, upward forces equal to downward forces. Upward forces equal to downward forces. And number two, principle of moments must hold. Number two, principle of moments must hold. right? Principle of moments must hold, right? So I'll give you a little note on this, right? Right, I'll explain what this means here. Ready? The principle of moments states that for a system to be in equilibrium, the principle of moments states that for a system to be in equilibrium, the sum of the anti-clockwise moments, the sum of the anti-clockwise moments about a pivot is equal to the sum of the anti-clockwise moments is equal to the sum of the anti-clockwise moments about the same pivot. About the same pivot. Okay? This here is the same thing. What should this is saying, right? This formula is saying the sum, that little formula, can you this means the sum of the anti-clockwise moments is equal to the sum of the clockwise moments. All right? So this saying the same thing like the little definition I gave you. All right? So we're gonna try to apply it formally now, but you all did it in the little examples, right? So let's begin with example 1. This is one of the hardest topics in mechanics. Right? So watch this here. Let's say that the system I drew on the board is in equilibrium. Right? For that to be in equilibrium, right? For this system to be in equilibrium, everything I draw is in equilibrium, right? So just note they are in equilibrium. Everything I draw is in equilibrium. So for that system to be in equilibrium, right? What must happen again? Upward equal to downward, or clockwise equal to anti-clockwise. Okay? Right? One of the things that you would recognize here is that this pivot is applying an upward force here. That's a law called Newton's third law, right? So I'll just call it R. It's called the reaction force, right? If you were to put your two fingers together, one of the fingers applying a force on the one underneath, and the one underneath applying a force on top, right? Those are called contact forces. If you touch the wall, you are applying a force to the wall, and the wall applying a force to you. That's one of the reasons why you feel it. If you on the ground, you are feeling the ground, right? You are applying a force to the ground, and the ground is applying a force back onto you. That is called the contact force. Right? We didn't formally do it as yet, but that's one of Newton's laws. Okay? So let's find X, and then we will find R, right? So how do we find X? In order for a system to be in equilibrium, principle of moments must hold. So the anti-clockwise moments must be equal to the clockwise. So does R have any moment? No, so we can ignore R, right? So we, huh? Yeah, you will get a fraction. So you're going to get the sum of the anti-clockwise is equal to the sum of the clockwise. So question, which of these is anti-clockwise? 4. Which one clockwise? 5. So what the question, what the formula says? Anti-clockwise moment. So how do I find the anti-clockwise moment? The 4 multiplied by the distance away from the pivot. Right? The 4 is 2 meters away. You okay with that? What about x? How far is x on the pivot? 5. So again, 8 is equal to 5x. X is equal to 8 divided by 5. That correct? No. 4 should be in. There you go. 8 over 5 Newton. Everybody okay with that? Yeah? So this is technically what you did a little while ago. Right? When we were doing the example, this is technically what you were doing. You were trying to make sure that the clockwise and the anti-clockwise are equal for the trash can and the next thing. All right? So what's some help here? How again R do? So you will always notice before you start, write the rule you're using. So the rule you're using is what? Upward forces. Upward force is equal to the upward force is equal to the downward force. The only upward force we have there is R, and the downward force that we have here is 4 and x. You see that? Upward is R, downward is 4 and x. So that's 4 plus 8 over 5. That's okay? That's what? 5.6. Are you okay with that? That's it. So you can see. All right, copy it up. Let's go again. Everybody okay with this? Right? So all you have to learn to figure out is, okay, which are clockwise, which are anti-clockwise. Plug them in the formula and work it out. Press cookie, that's something.
We got that, so it's about, we click it, and we did not plug the TV and stuff. Okay,
Yeah, I think it's like a shock tower.
Yes, just as anything else, that's one of the hours. No, you need to one from that.
and then get back to your screen there.
Right. Ready? Try this one here now. So what you will recognize, all I did here, just like the example we did, I put two objects on one and one on the next. See if you can figure out X. Take your time, identify which are clockwise, which are clockwise. Remember the thing said sum, right? So if I give you two anti-clockwise or two clockwise, you have to sum them up. Which ones are anti-clockwise? Three and three alone? Which are clockwise? Next two, right? So put them together. Hurry up. Presley. Pauline. Angelique. Tanya. Fan. Jan. What is that? Rachel. Curry. Carissa. Clifford. Clifford. Sasha. Shiraz. Ariel. Justin. Justin. Celine. Oh, Celine online. All right, so watch this here. So how do we do this here? So we check it to see what's clockwise, right? So we recognize, sorry, anti-clockwise. So the anti-clockwise is 3 and the distance away is 4. And clockwise now is x. How far is x on the pivot? And then 2 as well is anti-clockwise, right? But how far away is 2 from the pivot? 2 meters. So you have to add 1 and 1. So that'll give you 2. So here is 12. Here's x plus 4. Move across the 4. You'll get x is equal to 8 newtons. That's okay? What you all did, you all used 1 here. Right? So remember it's distance from the pivot. All right? You got that, Matthias? I want to show you what the actual past paper will look like. I'm gonna give you one like this, one more like this. Online, are you okay? That's not the answer. Right? Put out on the LMS. Right, so you can start from right there. Right, so you plus, so I'm gonna try not only in one time. Solve for x. Solve for x.
Yeah, yeah, yeah. This makes a little sense.
Oh, oh. Yeah. Yeah, it was like, oh, you know, it's eight, and 7, it's 9. We should draw it down because it.
You know, I could be. Let me show you this.
Mine's always like contact words.
You buy them nice. It's,
What's the one?
I like this one.
Yes, sure. And the prep.
You have to draw that line very down.
Huh?
Draw it long, long, long.
I beg you, beg you.
Long.
I just think it's practice. Can we share that? Or is it in the back there? Can we share that?
No, it's left.
Or how they get through them?
No. He just sent something, we got a passport.
What we send the list. Coming to them, that's now. Yeah, coming to all you. Right, so let's take a look at this and then we will stop on your okay. Make sure you get the elements, right? So first thing, sum of anti-clockwise is equal to the sum of the clockwise here. Right? Anti-clockwise will be 8. How far is the 8?
5.
5. How far is 10? How far is X? And how far is 7? 2 plus 1, right? So here is 40 plus 20. Here's X plus 21. So this is 60 minus 21 is X. Right? So I got X to be 39 Newton. Okay? So that's the principle of moments there. Next thing, what we'll do is we'll go into the past paper. But before you go, use the next 5 minutes to make sure you get onto the LMS, please. Those who online message the admin in the groups, and he will put you onto the LMS.